Good morning, everyone, and thank you for joining us. Welcome to today's webinar, Wood Framed Buildings, Design and Construction Challenges You Need to Know. I'm Lucas Evenson, Business Development Manager here at Braun Intertech, and I'll be your host for the morning. Before we get into the presentations, I just want to tackle a couple of housekeeping items. Everyone watching today's presentation will receive a follow-up email that contains the recorded version of today's webinar, along with a PDF version of the slide deck. CEUs will come in a separate email within about a week. Please note, if you would like to claim AIA accredited CEUs, you will need to provide us with your AIA member number when you complete the short survey at the end of this webinar. We will have a question and answer section at the end of the webinar, but would certainly love to hear from you during the presentation. We've got Jason and Steve. These guys are industry experts with a ton of knowledge, and they love to answer questions. So if there's anything that comes to mind while they're talking about a certain topic, please type your question into the question box, and I'll do my best to get those fit into the presentation as we go. And if we don't get them, then we'll get them at the end. And so without further ado, I'd like to introduce today's speakers, Jason Hanlon and Steve Flayton. Jason is a principal engineer in our Minneapolis, Minnesota office. He brings more than 20 years of structural engineering experience in everything from design of single-family structures to full structural design and detailing of multi-story steel-framed office buildings. Jason has experience with the design and investigation of all types of building materials that include wood, steel, masonry, concrete, aluminum, light gauge steel studs, and multi-wide brick. Steve Flayton is a principal architect, recently retired in our Minneapolis office. As an architect in Building and Structure Sciences Group, Steve helps solve clients' problems with building envelopes. He's got 30 years of experience, and he also evaluates the condition of existing buildings and potential acquisitions. With that, I will hand it over to Jason.
Thank you, Lucas. Thanks everyone for joining us, and for those that were able to kind of continue with our kind of scheduling readjustment that we had to do. So apologize that we had to cancel earlier on, but thank you for joining us here today. So just a couple of housekeeping slides up here on the front, just for the AIA credits, and move kind of through these ones fairly quick. But generally, what we're going to be talking about here, the learning objectives for this one, I won't read these verbatim, but the four main items are: understand general special inspection requirements for wood framing construction, learn about fire stopping requirements in wood frame structures. We're going to explore some construction defects that occur when details are not fully developed, and then also explore some most common design and construction defects related to building enclosures that allow moisture accumulation. So kind of a high level agenda that we'll be walking through here. So wood special inspections, I'll be going over the framing, more of the structural framing components. I'll then turn it over to Steve to go into detail on the fire stopping and EIFS wood special inspections. And then at the end, we'll be having three case studies that we'll talk through, and then hopefully have time at the end for additional questions and answers, as Lucas mentioned here. So as far as wood special inspections for framing, I'll be talking on just kind of a brief history, some common field coordination issues, and then wrap it up with some tips that we have kind of found that helps with success from a special inspection and even just a construction process procedure point. So brief history. I started mid-late 1990s. At that time, we were using the Uniform Building Code. They had obviously a special inspection chapter that was on there, but it was kind of more of a list and not as organized as it is today underneath the IBC. So I'll be kind of talking here a little bit more from basically the 2000 IBC to current, just kind of some of the changes that have occurred. We'll be talking pretty high level here, but just it's always good to kind of understand where we were and how we got to where we're currently at here today. So the history, IBC Chapter 17 is the primary chapter for special inspections. In 2000, basically the only thing that was identified from a wood special inspection standpoint was for prefabricated components and assemblies. So basically your pre-manufactured trusses fall underneath this category. There were quality assurance plans that had seismic and wind resistance. Basically, it was up to the engineer of record to prepare this, the contractor to acknowledge this quality assurance plans. And really, the only thing from these quality assurance plans, the notes that were in there, the seismic resistance sections was the one that had any information as it relates to wood framing. To move into 2003, similar to 2000, but adding a specific section for high load diaphragms. Basically, this is for horizontal diaphragms, floor, roof diaphragms that are designed using the load tables in the IBC, and the requirements for special inspections were just inspecting the nail patterns and conformance with framing sizes. In 2006, continuing to have the high load diaphragm section is in there. They actually removed the quality assurance plan section and added the seismic and wind statement of special inspection. Again, the seismic references the structural wood components, but the wind section still did not have any direct reference to wood framing. There's comments about lateral resisting systems, but it didn't have a direct correlation with wood framing at that time. So it was still a bit vague at that point. 2009, the code added a section for temporary inspection of temporary bracing for prefabricated trusses spanning 60 feet or greater. And then also the wind resistance section now has a reference for wood framing components in it as well. 2012, it was just more of a reorganization of the two sections and that statement of special inspection section. And then 2015 is just kind of more of updating and clarifying some text that was occurring. So currently, for the most part, I think majority of the country is operating underneath the 2018 International Building Code. There's basically three sections that specifically reference wood special inspections or some level of it. There is an item in there, an exception that special inspections are not required for light frame construction, wood framing, but that has to only if it meets the provisions that are outlined underneath section 2308 of the IBC, which is pretty limiting anyways, and I'll go into a little bit more detail on that during one of the case studies. But otherwise, what special inspections would fall underneath these three sections that I'll go through here, and also anything else that the engineer of record might determine is required based on the complexity of the building. So 1705.5 is wood construction. That's basically the prefabricated elements, our high load diaphragms that have been in there since 2003, identifying sheathing, grade, and thickness, size, and for framing along the panel edges of the sheathing, and panel edges of the diaphragm, and then nailing size and spacing. We have our permanent bracing that needs to have special inspections for prefab trusses that are over 5 feet tall or 5 feet tall and taller. And then also special inspection for the temporary bracing of trusses spanning 60 feet or greater. Second section that's there, 1705.11 for wind resistance. This one is identifying that special inspections required for when we have wind exposure category B and 120 mile per hour wind speed or greater, and then for category C and 110 mile per hour wind speed or greater. And for these conditions, they're requiring continuous special inspections for field gluing of the wind resistance system, And then also periodic inspections for nailing, bolting, anchoring for shear walls, diaphragms, drag struts, braces, and hold downs. And the third one, special inspection for seismic resistance, similar to the wind resistance when it comes to the type of inspections, but identifying where this falls under which seismic design category. Just to touch on some updates for the 2021 IBC, as we're now moving towards the end of 2020 and going into 2021, it will probably be still a bit before this code is adopted in mass throughout the country, but some things to kind of be aware of. There's a mass timber special inspection section that's been added. Basically, it's for construction techniques using large solid wood panels for either walls, floors, or roofs. The ICC is in conjunction with the AWC has a tall mass timber building special inspector certification program that's out there for further education and training into these requirements. So just something to keep in mind as we're moving forward, and this seems to be a construction technique that is gaining some steam and has been used in a few of the markets throughout the country. So basically what they're providing is a more of a table format of what's going to be required for continuous and periodic special inspection. And then the other item to be aware of is the change in the wind speed for special inspection requirements. This is one that I personally haven't dove into too deep as to how this is going to relate to a lot of things, but it's interesting that it's moving up from category B, where we were at 120 miles per hour, to now we're at 150 miles per hour. I know that there's been some discussion and some thoughts of how the wind pressures were calculated, and I think there's some of that information that was kind of provided to kind of relate to this change that's potentially coming up here, but I'm sure that there's going to be more to come that's going to be presented by the AICC when this thing gets rolled out. So just wanted people to be aware, because it is something that needs to be considered as we're kind of moving through time. So as far as qualifications for wood special inspectors, the IBC does not have any specific qualification requirements. Basically what they're indicating, and this is pretty much for most of our special inspectors, but there is obviously for some instances and framing techniques outside of wood to have certain level of training and certifications. But for wood special inspection, it's needing to show documentation of competence, and any whether it's your experience is having the level of inspection, on the job training, so to speak, or understanding of just framing techniques. If it's a person that's coming from a different trade, construction trade, that's now into the special inspections. Some states and municipalities do have specific requirements. I know Washington State does have their certification requirements because of the seismic design requirements that are out on that side of the country. But for the most part, what we end up experiencing from when there is a question, or if the building official is wanting to know, is if it's a licensed engineer that's providing training to the special inspectors, or if it's just what the background is of the individual, and then going from there. So most building officials do find that having an increased involvement from the engineer of record during the construction kind of helps with the inspection process. we end up finding that if there's a kickoff meeting prior to the start of framing, that it's not just the special inspector and the contractor, but if the engineer of record can be out there during those kickoff meetings, that is very helpful for identifying any potential sticking points that might be there. I'll kind of go into some of the potential issues that we've kind of encountered throughout the time, but even just walking with the inspector during that first visit, if the engineer of record can be out there and help with that kind of first initial pass through, it'll end up catching some things that will help just as the construction process moves along. So very important that if whenever possible, if the engineer of record can help be part of that initial discussion, it helps the whole construction process along a lot easier. So just some examples of kind of the levels of different special inspection notes, requirements that we see from time to time on different projects. It can be something as very simple, one line coming across, kind of identifying it to something that's a little bit more in further detail. So once we get into situations like this where we have 5 to 6, 7 items of wood special inspections that we as inspectors are needing to understand and to look at, the more involvement from the engineer of record up front, the better it is to make sure that we're catching things as much as possible. So from a special inspection standpoint. Some common field coordination issues. So connections of the floor and roof framing at the top of the wall seems to be an issue that we'll encounter from time to time. Drag strut placements, if that's in line with the shear wall correctly, where those are identified. Shear wall construction, when we have either the plywood OSB sheathing, is it that or is it the gypsum sheathing? Once the gypsum sheathing is introduced as part of the structural system, the structural resisting system, it introduces a new tray to the construction, and just another person, another piece to coordinate and make sure that everyone's on board and understanding what the requirement is for that system there. And last one there is just pull down anchor placement and installation. Is it post installed anchor? Is it is it supposed to be a cast in place anchor? How are things lining up there? Just some challenges that we do find that can happen from time to time. Just some examples of some details here of the things that I just was covering. Drag strut, making sure that is in line with that shear wall that's there on the left-hand side. Making sure the contractor is aware that framing needs to happen and in line accordingly. Pull down anchors if there's tight groupings of them. Usually there might be some issues with how many studs are in those areas, and just kind of creates a tight situation. And then as another potential issue is just the varying spacing of the nails along the panel edges. We have a condition here where we range from 2 inches on center to 6 inches on center, and whenever it's possible to try to keep a little bit more consistent, not have as many options or as many different scenarios for nailing patterns, the better, because those are things that can happen where somebody might say, is it okay for us to do 2 inches on center everywhere, just so they make sure that they have it? But that's not necessarily something that from a design engineer standpoint would be a good thing, because sometimes you need to have your shear walls perform in a certain way and not be too rigid. So just items to be aware of going through and trying to identify and simplify things a little bit. Another challenge is when we have a shear wall with blocking and making sure that the blocking is placed accordingly. Also understanding that the pattern of the sheathing needs to be staggered and in the horizontal direction versus tipped upright in the vertical direction, because it's different. Those two types of placement of the sheathing have a different performance depending on what the nailing pattern and what the blocking needs to be. So, and also just from a constructability standpoint, understanding how the sheathing is going to be placed on shear walls. Is it going to make sense to have the sheathing on the interior side of a double stud common wall? You know, how is that being coordinated from a construction standpoint? You know, just things to keep in mind as you're moving through and trying to make things as constructible and easy to interpret for the contractor and for the inspector out in the field. And then just lastly, this is, you know, we have situations where this is a shear wall schedule. Obviously, you can see there's a lot of different scenarios that are occurring. And then this particular one, we have basically along a shear wall from level 2 up to level 6. We range from wood sheathing on the bottom level all the way up to a 5/8 gypboard on the top level, and just making sure that those types of things are coordinated out correctly. So, so just some visuals of some of the things that I was just talking about here. We'll get called out to the field. I did saying that framing is complete. Come out and do our inspection. I see where things are at. Here we have strapping that is, hold down strapping that's supposed to be continuous up to the level above, but it is not nailed to the studs below. We even have a condition where there's a strap that's right in line with nothing. There isn't a stud there that's in line with it. So just kind of obviously a misunderstanding of what the detail was needing to do and to how it was supposed to be implemented. And items like this could be caught fairly easily with a initial walkthrough with the engineer of record, just to make sure that things like this can get caught. Hold down anchor placement. Obviously the holes were started, but the hold down anchor is here to the right, not in place. A little bit of a situation of clearance issues, trying to get things lined up appropriately. So just some of those constructability challenges that are out there. Wood blocking that's in place but was not placed on the remaining part of the joists. Just making sure that those types of details are understood. And then here we have a situation where we have blocking, horizontal blocking that's supposed to be continuous through the wall. Unfortunately, that is not happening because of the conduit and the pipes that are in place, and even resulting in the pipe there on the right hand side actually having a nail penetrate through. So it's just another example of some things that might come up as best intentions are laid forward with the details, but sometimes the construction of other trades might get in the way and needing to accommodate those types of things accordingly. So hold down anchors, we got the 3 that are here, but yet not continuing through as intended. So just some tips for success that kind of come up. Simplify the requirements, limit multiple types of shear walls as much as possible. I know that it isn't always, especially when you have the more levels of flooring you have above that you're going up, the more types of shear walls that are going to be needed, especially on the lower levels. But when things can be limited as much as possible, it definitely helps from a construction standpoint, and even repeatable detailing when possible, and not having multiple types of hold down anchors that are placed throughout can help with relieving some of those challenges that might come up. Clear detailing for anchoring and strapping, and the big thing, and I've said it a few times already, is just that engineer of record engagement early on in the process will go a long way with helping with from the wood framing standpoint. So with that is the end of the framing section of it. I'm going to turn it over to Steve Flayton to talk about fire stopping and EIFS special inspections.
Thanks a lot, Jason. A lot of these things we're talking to you about special inspections have changed over time. I started in this industry in 1974, and special inspections never existed then, and it's continued to proliferate, primarily because not all the building officials have all the knowledge of all the specialty things we're doing and how we're using materials in very technical roles. So keep that in mind, that that's where this is kind of coming from. The fire stopping section we're going to talk about, again, is a special inspection item under Chapter 17. And you'll see here we've listed, it was very specifically addressed in 2012 IBC. This deals with penetrations of walls, floors, edges, roof ceiling assemblies. It's conduit or penetrations, expansion joints, you might say, penetrations through walls, even firewalls that have electrical boxes in them for light switches and electrical outlets sometimes require these special inspection or to substantiate that they've got the packing around the back side of them. So many times, people think of fire stopping as, taking the red caulk and smearing it around a couple of wires that are going through the wall. That seldom is, found to be in good shape or some meeting all the requirements. So the 2018 IBC under Section 17 here has these risk categories listed, and they're listed back in 1604.5. Now these categories, it's not a construction type, we'll oftentimes see, type 4 construction. No, this is the category, the risk category. So these are buildings that have high occupancies, schools, assembly areas, buildings of particular concern for public safety, being fire departments, police departments, city halls. They're very also with schools. You can look at the chapter and go through there, whether it's children and whether it's over 300 participants or occupants in the space. Those kind of things is what triggers this inspection to be done. The inspections get done according to these two ASTM, one for penetration, the other for joints. And in there, there's also discussion on what are the criteria for having a special inspector. Fire stopping has gotten to be a very technical business. So next slide. Some of the cities have taken on the special inspections themselves. I know Bloomington and, with the Mall of America and things, they've decided to take that category on themselves rather than having a special inspector do it. Some of this as well as EIFS inspection that we'll talk about shortly are items that don't show up in the normal special inspection sheet that the cities are using. So, you need to ask about those things if they're going to require it, because fire stopping, for example, needs to be done during the process, not something that pops in later in the process. We like to see a assembly listed for each type of condition. If it's a 1 hour wall, it's a smoke and fire wall, or it's just a smoke wall, it's just a firewall. Those assemblies vary, and it depends on the type of materials that you have. So having thought through it, having it written down so that a vendor such as Hilti or 3M or others that supply these materials can actually put an assembly together for you in a shop drawing listing. That's kind of the guiding light that goes forward. We use those things as the inspection proceeds to verify things like, is it plastic or is it steel conduit? Is it a sleeve that goes through and what is that material. And we compare that to make sure that everything meets the specified systems that are there. You know, with the type of packing material, the brand of the material, how it's screwed together. Next item, please. Sleeving is an important thing. You know, we have sleeves that go through around fire dampers. Those are an area that do not have sealant applied around the perimeter of the red caulking, because that is an intumescent material that when it heats up, expands, and it would jam up the operation of smoke and fire dampers. So, you know, again, if this is one of those places, you make sure that somebody's not gotten carried away with the caulking. The means of application is the stuff pinned in place, testing a number of areas. We're required to look at this as 100% visual inspection, making sure that all the openings are done. If you do not observe the installation being done firsthand, it may require to cut open areas, make sure that the proper mineral fiber packing is present in there, how thick is the sealant materials that are put in, and we'll in some cases cut these things open, which means now you got to go back and repair it. So doing it during construction is important. We oftentimes will get called in at the end of a project and said, hey, the building official says we need to have a special inspection form signed off on fire stopping. Sorry guys, but we haven't seen it take place. And you've got it all over the place. You got hard ceilings in, you got layers of sheetrock in. You know, you literally have to cut holes in the walls to find these things out, and we've had to do that. So finding out this stuff early on, getting it in the list, and getting it done during the process, very important. Next item, please. So, you know, these installation, again, as I mentioned, you know, steel versus plastic sleeving. If the pipe going through it is steel or plastic, if you have a lot of conduits or a lot of loose wires going through certain areas, there are manufactured assemblies by like 3M, Hilti, et cetera, that you can drill a hole through the wall, slide this thing in. It's already got the fire stopping materials inside of it. It allows you to slide wires through. So if you have a school or an office building that's got a lot of IT concerns and loose wire going back and forth through it, that it allows variations and adjustments to take place over time. The fillet size, you know, the sealant that does get put around the red caulking or other colors as well, based on the assemblies, we do have to look at those things. You know, it's like looking at a weld. Is that fillet, you know, 3/8 of an inch on each side, and we've got the proper thickness, so the proper materials there when it swells up, and there's just not a real thin coating that's been put over things. Is there any kind of an unusual situation that arises? It always happens that we get to something where there is not an assembly through UL or others that have published these documents that tell us exactly how to do certain things. Slab edges are often this type of thing where the floor comes out to the edge of a curtain wall, and how do we seal from that curtain wall back to the slab edge? Okay, well, that works great if it's 4, 5, 6 inches. Well, what happens, I think the stadium downtown Minneapolis for the Vikings was one of those that had this extremely wide gap that developed there, and that required what's called an engineering judgment. So because it has not been fire tested and proven, it requires the manufacturer to look at this condition and use their best judgment of how their materials perform. And maybe they have an assembly that isn't even published yet. And those kind of things are necessary to help with that professional engineering judgment that they give you then. All right, this is what we would suggest you do. You talk with the building official and, you know, engage those things. And again, red caulking is not the only solution. It's not the way to do it. It's different than it used to be done 5, 10 years ago. So be cautious. Next item, please. EIFS special inspections. Again, in section 17, this comes out. And the areas that do have some exceptions that does not require special inspections. Over time, we had what was called a barrier system, that what you saw standing outside the building was the barrier. The caulking, the finish coat, you know, and how it was sealed to other surfaces. Any water was not supposed to get through what you could see. Eventually, that's moved on to using a drainable system. which has a drainage plane and a weather barrier behind it. So EIFS and special inspection is not required over concrete or masonry, and it is not required over an approved weather resistive barrier. Most of the manufacturers now have a weather resistive barrier that gets put on. I will tell you that over plywood, most of them do not like that. They won't approve their coating over a plywood. They may require something like a Tyvek and then the coating over the top of that. And then the foam be mechanically attached. The application of the adhesive, it does go to, say, a weather barrier that's been applied over gypsum sheathing. That material has to run vertically so the drainage plane runs. Now you also have to have details of how it's required to be flashed back out, just like you would have with any other kind of a rain screen wall or other masonry wall. You have flashing sweeps and how you get the water back out of there. All that stuff's got to be inspected. Next item. So some of the problem areas we see is the weather resistive barrier. If you've got something that's Tyvek on behind brick or building paper and suddenly you change to EIFS, I've seen too many cases where the masons try and do a nice neat job and they cut the weather barrier off right at the edge of the brick. And then the EIFS guy comes in, well, how am I supposed to overlap this stuff when it's behind the brick? Or any transition materials such as metal siding, composite panels, etc. The drainage plane needs to drain. It needs to drain to the outside. Consider where you have expansion joints, where you have windows meeting, and how the jam and head applications are handled in those locations. Corner details is one of the things that we see very frequently being done incorrectly. The insulation at a corner of a window, for example, needs to be cut into an L-shaped piece, not a vertical piece that butts to the jamb and a horizontal piece that butts to the sill, and there's a gap that exists there, or a joint. The materials we'll show you in some of the case studies will crack along those areas. There is also, in most cases, a diagonal piece of mesh, additional reinforcement that's supposed to go over those areas and cover that. Floor line joints, we're talking wood frame here today, and the physics of materials is brick is delivered to the site as small as it will ever be. Block comes as big as it'll ever be. Stone, pretty much stays about the same, but the wood frame structure shrinks over time, both from wood shrinkage as well as compression, and that happens to be about 1/2 to 1/4 inch per foot. This is additive, so if we've got 6-story wood frame buildings now, and you have any kind of a load-bearing masonry, the masonry is going to get bigger, the frame's going to get smaller, and guess what? The brick window sills start passing up into the sill of the window openings, and things stop functioning, such as operable windows. I've seen things happen in buildings where they've gone around the perimeter as installing the EIFS, and by the time they got back to the starting point, there was almost 3/4 of an inch difference where the top and bottom of the EIFS ended. It was not a good condition, so they had to go back and refit some things. Next item, please. Control joints, expansion joints, the little V grooves that are cut in, little reveal joints, these are not necessarily expansion joints. That's usually the first place it'll crack, and it starts near window corners. But you need to have expansion joints on your floor-to-floor elevations. At rim joists, V cuts, again, are not adequate for those type of things. Think about that rim joist. Also, you have to, if you've got a weather resistant barrier behind there, you need to drain that out and have some flashing. Weather resistant barriers need to be continuous, again, across that brick to EIFS, EIFS to siding, EIFS at windows, wrapping the weather barrier into the openings, getting those things sealed off. Where is your weather cutoff point on a window? Your primary seal, is it at the thermal breaks in the windows or at the outside? Those things all have to be considered. Next item. And I'm going to have Jason take it away from here.
Perfect, thanks, Steve. So we're going into just some case studies here. We'll have 3 of them that we'll go through. I'm going to start on this first one, kind of go into the second one, and then Steve will jump in again there. So first one here that we have is townhome structure that was built back in 2005. Basically built in 2005 and it was constructed underneath the 2000 IBC. So we're very early on in the IBC brief history that I kind of touched on initially. So the claim was that there was lack of lateral force resisting systems for these townhome structures. There's no braced wall panels that were clearly identified in the construction documents, and unfortunately, and no one can really, we weren't able to figure out why this didn't happen, but there wasn't an engineer of record that was shown on the record documents that were provided to us. So assuming that the buildings, since there was no engineer of record, they were assuming that the buildings were supposed to be constructed underneath the provisions of Chapter 23 of the IBC. But unfortunately, what was being found was that those provisions, that the buildings actually exceeded the provisions that were outlined in there. So there was concern that there was an immediate, or not, I guess I shouldn't say immediate, but there was a life safety concern, that there was a lack of lateral force resisting systems, basically shear walls, and no brace wall panels that could be clearly identified, and so that's where this claim came in. The interesting thing with this, so it's three buildings that were of concern. It's the three here on the two on the top and the one here on the right. It's basically a row home. We have the garages on one side, your front entrance on the other side, and then there's common walls that are in between each of the units, to kind of give you a plan layout of what this would typically look like. So the span of the trusses were greater than what was acceptable under that provisions of Chapter 23. The actual spacing of the common walls was greater than what was acceptable for the provisions of 23. But what we were finding as we ended up doing the review, and part of the reason that I did bring this one into this webinar is it's a project that was built under the 2000 IBC. We didn't get involved with it until 2016. So we've gone through a number of code cycles that have occurred, and just kind of interesting to kind of see how things have progressed, because as this thing would have been designed to the more current IBC standards, there would be that it would have been identified that this is not meeting the provisions of Chapter 23. It's in an area that wind speeds would have required special inspections, and needed to be identified, and the fact that this was kind of so early on in the process, the construction documents that were provided did have some level of engineering oversight from what we were able to determine, because of some of the requirements of the framing around the garage panels. Either side of the garage panels were actually sheathed different than what the rest of the building were to accommodate the lateral bracing there. So there's just some types of indication that there was some engineering oversight, but you got a two-story, it's very common type of construction, two-story building, townhome building, common walls, and being able to kind of just go through, and it would be typically done under normal IBC, and would special inspections would be required for this type of situation. So just an example of potential wind resistance system issues that can occur. The second one here that we have is a three-story building. It's a three-story long-term care clinic constructed in 2008. There's some issues with interior and exterior distress. There's some excessive floor settlement, floor deflection that was occurring, and kitchen space and near a large fireplace. And we also had some shrinkage in the stairwell post that I'll show you here in a second, along with some stone veneer cracking that was occurring. So basically what we have, original design intent for the stone fireplace that's shown here in the picture was the stone veneer was only supposed to go up about 3 feet above finished floor elevation, and actually ended up going up to full ceiling height. The conditions around this fireplace, as you can imagine, as you go from one side of the room towards the fireplace, there is a dip in the floor that's occurring. We're measuring about an inch of deflection that was occurring at that point. Is probably more noticeable as you're walking from left to right in this area. So, reviewing of the construction documents showed that the trusses were actually designed to meet allowable deflection criteria. Taking a live load of 40 pounds per square foot across the entire floor system, even with the weight of the brick fireplace there in the center, the deflection criteria was still meeting what the code prescribed. The unfortunate thing is that when you have a stone, this stone veneer fireplace there in the center that has that permanent load that's occurring at that location 100% of the time, the other areas that were designed for 40 pounds per square foot are not seeing that on 100% of the time. So that area is going to end up deflecting and showing a lot more than the rest of the area because of that permanent loading that was happening there. So just some conditions to be considered when doing a layout of the floor system, that even though with full design loads that are on there, if it's not taken into consideration of some of the permanent loads and what that would end up showing, presenting itself from a long-term standpoint, there are going to be some things that pop up that may not be ideal or acceptable to the client, the long-term resident for the building. Similar situation here with the kitchen. We have cabinet condition cabinets that are constructed all the way around in this kitchen area. The side on the right is actually just an interior partition wall. There isn't a bearing wall that's there on the right hand side on the other side of these cabinets. And because of this facility, these areas are loaded pretty full for a lot of the times that they're there. So there's a lot of weight, a lot of self weight that's coming down onto this situation. And as you can imagine, we had the floor would deflect more from on the right side versus the left side. So we had that transition that was occurring there. So just again, keeping in mind of what permanent loads, even though it's meeting design intent, permanent loads can have an effect on how the structure is performing. In the stairwell that we had at this situation, the way the construction documents were shown, there was supposed to be basically a transition from each landing where we had the post would go up. There would be a splice point, whether with some type of transition strapping going from one landing to the next landing. Once we ended up exposing the condition, we found that the post is actually a continuous post all the way up through the entire height of the stairwell. And in addition to that, once we kind of uncovered things a little bit more, the post was actually notched in a situation here. So basically, and Steve kind of mentioned a little bit about this with how wood shrinks. With the longer continuous post, that is allowing to shrink in a lot different manner than if it was separate post that were spliced together. So if this detail would have been done the way that it was constructed, we probably would have not have seen the ripping of the tape joints and such like that on there. So Steve, do you want to talk about the stone veneer situation here?
Sure, thank you. Again, we have wood framing behind this, and stone stays about the same size. Well, there were several things that took place. On the right-hand side, you can kind of see where the weather barrier is there. Anybody see any brick ties? There should be several of them present, but we found much fewer than was supposed to be there. In some cases, towards the top of the wall and the parapets, there were no attachments. So we had too many square feet of veneer per anchor, and in some cases, no anchors at the top of things, and these pieces bowed out. You also get a variation that takes place between the stone and the brick, for example. Some of the stone would sit on top of the wood frame walls, and that was causing some difficulties as well with cracking and splitting of the mortar joints between the stones. This is one of those prime examples. Like I say, if this stone stays the same and the building shrinks, the stuff you can see in the stone there, those windows would be pinching and stop operating. One of the classic signs of this is if you look at the jambs, you will see this sort of zigzag pattern of tears along the caulk joint from the head to the sill. You may see or may not at the head and sill, the caulk joint being just fine. You need to accommodate that. You need to accommodate in your sills typically. An expansion flashing, particularly when you go up higher than this, because that sill will end up rising and the structure will start falling. One of the other failures we saw was that there was a through wall flashing. There was a lintel that was bearing on the stone on either side and was attached to the structure. In some cases, again, wood making it move. In other cases, it was loose and it was rotating. Or there was a double angle that was put in, and that angle would rotate and cause the stone to move in and out. So those things had to be done. We recommended putting in some additional vertical expansion joints so that as the building goes around the corners and changes character a little bit, that the joints are controlled there. Next slide, please. So let's talk briefly on some of the EIFS failures. This is one of those corners I was talking about earlier where we needed the additional mesh installed and the foam. If you cut this thing open, you'll find that that foam joint goes straight up and down vertically, and that's why the crack is taking place there. Next slide. Sometimes water gets in at the top. It's always important to flash over the top of an EIFS system like this, even if it's drainable, because what happens is the joints in the flashing do not seal. Many people believe that we caulk between the pieces of metal on the copings, and that seals things up. That lasts maybe the first summer, and as expansion contraction moves, those joints start to leak and water gets in behind the panels. And what you're seeing here is moisture within the foam in an EIFS system. Next item. Talked about what happens between stone and EIFS. So here's one of those examples, and it's just made even worse by having the lamb's tongue, drainage system coming out there. The floor level is right about the top of this drainage trough, and what's happened is the joint, there was a caulk joint there right at the top. You can see just to the left and below the drain that there's a caulk joint that has failed. That caulk joint happens to be the same elevation as the floor. Guess what? The floor inside was wet to, the carpet got all saturated, the cabinetry got all saturated, and that's just essentially a failure of the caulk joint, which is, in this case, the primary seal. Next item. There's a couple of things you can see, the joints that are put in, the reveals. But you got to look a little bit closer. You'll see there's kind of a mud cracking taking place. EIFS systems need to be put in this type of weather today at 40 degrees and rising through the day so the stuff can cure and not freeze. Or in the summer times where it's very sunny, south side, hot day, winds blowing, takes all the moisture right away, and guess what? The stuff flash dries like mud, which is why it looks like it's got mud cracking all over the place. Next picture. Here's the result of that. The finish coat is falling off of the base coat, and we're looking for different types of conditions. You can see just above this location where the material is falling off, there's a through wall flashing at the floor line. So that's a good result, and it moves around, does what it's supposed to. Next item.
Hey, Steve.
Yes.
Yeah, hey, Lucas here. Hey, there's about 5 minutes left, and I know you got a few more slides. I just wanted to jump in and remind everybody if there are any questions that you might have. I know they've been covering a lot of good content here, but if anybody's got any questions, feel free to type them in. If we run up against noon, then we can certainly get your questions answered, get back to you in an email or reach out to you if you have questions. So feel free to plug them into the questions box, and you can keep rolling if you want to there, Steve.
Okay, thank you, Lucas. The finish coat here, finish coat going into an expansion joint or a caulk joint is not acceptable in most cases. The finish coat has a tendency to break down with some moisture behind it, and you want to have just the base coat, and that can be base coat that you put with like a color prime material or something like that, so it matches the color, but it will allow it to bond. We often recommend that use of EIFS systems like this, where you're going to have a caulk joint, use a pre-based section you can get from the manufacturers, and you put the stuff together, and then you're assured a quality joint instead of having, as you can see here, the mesh kind of a little raggedy on the left hand side going around. And the caulk joint does pull on those things and can sometimes delaminate those as well. Next slide, please. Here's what happens in wood framing if you don't handle some of that flashing. You'll see this stuff reading through, and this is not a moisture issue. It will be because the wall's now open, but it's just a compression and it just fails. Next item. I'm going to literally give you about a 60-second coverage on this and recommend that what you do is look on our on-demand website, at braunintertech.com, and look for what we call the rotting roof seminar. This is where I pulled some of these out. This is a very critical element today. It's not known by many people. It is an extremely expensive and traumatic type of thing that takes place. This is an opening in a roof. We're opening it because there's a bunch of problems such as this. This is what it looks like underneath. And the moisture comes through, rots. You can see here how the plywood is rotted, and it's all started to fall into the openings. It was like walking on a water bed. Next item, please. And you end up with air bypasses through things like sealing junction box here, or a layer of poly vapor retarder that is not sealed up. Next item. And this is what it looks like when you remove it. All that dark wood is rotted wood in the trusses. Just so you know, this was 3 years old. So the moisture coming through there, particularly with higher humidity areas, bathrooms, dryer vents, other things run through this ceiling roof space, pumps moisture into it, and that's what condenses on the bottom side. Next item. There's also air chutes that come up from the bottom into these areas, and you can see from the walls, you have to carry that vapor retarder all the way down, connect the wall to the roof and the parapet, seal things off so you don't get air circulating. Again, go back, take a look at this rotting roof seminar. It's about an hour in itself. And this is another bypass. As we started looking, this is in the truss space, and rooted around a little bit, and a board that was laid over this fell down on the opening. This is a framing between a bathroom, bathtub, and a closet that does not or did not get covered with a layer of poly. So next item. Here's your contacts. I'm going to throw it back to Lucas to wrap it up and see if we got any more questions.
Excellent. Thank you very much, Steve and Jason. So yeah, it looks like we're basically right up against our time here, and so I want to be certainly cognizant of everybody's time, and we appreciate everybody joining in. Let me just grab one thing here. So I'll tell you what, if you guys had questions, we'll make sure that we get back to folks. I didn't see any that didn't get kind of covered at the end there, Steve. So I just want to
Okay.
thank everybody for attending today's webinar. We will be sending out an email shortly after the presentation with a recording along with a short survey. And again, I just want to remind everybody that if you'd like to claim AIA credits, the CEUs, please provide us with your AIA number when you complete the short survey. Non-AIA CEUs will come in a separate email within about a week. Also, just want to remind you, please keep your eyes on your mailbox, your email box for future webinars. And if more questions come to mind, feel free to email them to Jason and they'll touch base and get back to you. So thanks again, everybody, and have a great day.